Hey, all right. Okay, wait. First, you guys gotta check this out, man. This thing is so cool. I'm vibe coding. All right, let's take All right, let's what do we want to start with? I probably gotta go. Okay, now I gotta go. Let's go like this. Okay, now let's go like this. Okay, now we got an internal alkyne. That kind of sucks, actually. Is there a way that we can? It's a. Let's actually go back. Let's go to propene. Oh wait. Now I'm gonna tell Codex also. Um, is it control slash? If I go to YouTube, sometimes it's shift slash, sometimes it's control slash. I think it's control slash for the most part. What's a website that I know has? Yeah, let's use control slash. Okay, if I click this to focus reagents, or if we are reset to focus the molecule. Bro, I love vibe coding. I'm actually like so. It took me so long to like just try out building something. But now that I know I can literally build anything, it's just like this thing is like okay. Orgo solver is like Orgo solver is really sick. I actually really like Orgo solver. Um, but like mine is like low key better. Okay, so let's just add BR or let's do HBR with ROR. Okay, we get the anti-Markovnikov. Now, oh wait, I want to try one. Uh, okay, wait, let's try this. I wanna reset. I'm gonna go to so it's gonna be BR CC this C this C like that. Okay, so I want it to maintain cis, but I'm gonna have so now I'm gonna add what's a good SN2 nucleophile? NaCN. Oh, and it stays. Is this right? I'm not positive that that's right. let's see. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. Okay, that's right. But anyways, the main thing that's sick is that the cis stereochemistry was maintained. That I had to fix that last night. What I want to do though is oh, also okay. Okay. Dude, I love vibe coding, man. All right, so wait, what do we want to do? We want to do like two the biggest problem for me right now is input. And it's funny because even PubChem input is, I mean, their input's pretty good, I have to say, but it's like still, you know, um I wonder how many people have services like bring your own key where I could put in a key and then I could just put this here and then it would ask a little AI uh for me. I would like to experiment with that actually. Bring your own key. Security concern up the wazoo, but you know. Anyways, what I 2-methyl bromocyclohexane. See, this is what I'm saying. Like, do they not have like an? I don't know. This seems insane. It's like I have to ask an AI to find. Is this even going to be right? Okay, so this is cis. Um, but we actually want trans. We'll give the Zaitsev alkene. But I'm looking for a ring case in which lack of anti-periplanar H requires Hoffman. Because if you see here, look, this conformer, there's a transdiaxial interaction here. So the base pulls off this hydrogen and we get a Zaitsev. Okay, so here we go. We got the trans. So I'm actually curious. But the thing is, I think that does this work? See, I think because you need a CID. Okay, so definitely we need wedges and dashes. But if okay, here I want to add. What's our standard ethoxide? Wait. ETO. Wait, actually, no, wait. No matter what. No, hold on. Let me think about this. Um. Wait. Oh, wait. So see how this conformer is not right? Here we go. So in this case, we don't have. So what we expect is that the alkene that forms, it has to be here, which is the minor. So, I mean, we have it. And do you get a mixture? You actually don't get a mixture because you don't get a mixture, I don't think. Um, so I don't know what the best way to handle this case is. Like, do we basically need to? I mean, if the stereochemistry is not provided, then what can we do? But if it is provided, then we need to check the likely. And I think really there's only two conformers that you check in the case of cyclohexane. You know, you check that the case where BR is axial and the case where BR is equatorial. And then you just look at neighbors and you say, is there an anti-periplanar? Then you sort the anti-periplanar by substitute, resultant alkene substitution count. And then you go from there. Because, because this case is wrong and this case is right. But I like that that at least it gave me the option. Like that's pretty cool. It just said that it was less likely than the other one, but I don't think that's actually true. Okay, let's see. Do I have the new version? Okay, escape does not get me out of the. Oh wait. Oh, dude, that's so fucking cool. That's so cool. Oh my god, that's so sick. I love vibe coding, man. So cash money. What I want to do actually is uh oh, okay, I got it. Here we go. Um okay, so I gotta fix that. I think there's another bug similar to the wait, actually, hold on. Not only did this bro. Okay, this one's really bad. So wait, let's try to okay. Cuz if we go here, it's cis. If we go here, it's trans. Obviously also the epoxide added to the wrong spot. So okay, so I think the most important thing is that if I chem rolls, wait, I want this, but I don't want to switch. Okay. I lost it. Wait. If I go here, I copy, I think I can just put this in, right? Okay, so that's correct. Now I want MCPBA. So that one added right. That's interesting. Wow. Okay. See, the most annoying thing though is that I can only connect to codecs on my phone. Oh, my 7 day, dude, my 7 day limit reset, bro. It's over. Dude, today is over, man. I gotta get a charger. Oh my gosh. Okay, so it's weird because why did this work? But then I think, you know what happened? I think when I put this in, this was the first alkene it found. So, like, it would have otherwise hit this. Alright, so let me get a charger. Okay. Okay, so, uh, what if I do this? Uh, okay, so I'm just gonna copy this, I think. So, Wait. Oh, wait, but this is missing the MCPBA part. Okay, wait, we need to copy this instead. Okay, so I gotta go back. Gotta copy. Gotta go back. Gotta paste it. Because here, this became trans. And it obviously it added here, which is totally wrong. Okay, so it's going to fix this case. So what do we need to do? We need to somehow get here. I mean, I think we could start with just... Am I still down? Am I live? I think I'm good. Okay. Alright. So, Alright, so we're just waiting for it to write the code now. But yeah, so basically the pathway, phenethyl bromide. Okay, SN2. And then here, Linlar, then MCPBA. And so that is the minimal thing. And presumably we could actually just go back to this. Right? I can just put this in. Or wait. No, but see here. It's gonna work. Is that right? I can't tell if that's right. Shouldn't it be down like this? Or does that not matter because these are sigmas? I think that since this is a sigma bond, that's okay. So I think that this is right, but we have to go back to the SN2 product. So we have to go back to phenethyl, or no, we have to go back to C minus hash CC, then phenethyl bromide, then Linlar, then MCPBA. And that is the minimal issue. Some insane bug. I caught the bug! Okay, so wait, hold on. I think it responded. Fixed and deployed. Dude, I just love, like, it makes coding so much more fun, dude. The MCPBA rule was using canonical smiles, so it saw the first benzene double bond as an alkene and epoxidized the ring. Now alkene reactions prefer structure Q when available, so aromatic rings are not treated as normal alkene targets. Okay. So let's see. Do I get a new commit? 840. All right, cool. So, well, what do we want? We want C. There's a B on me. There's a B. Get out of here, B. Okay, C minus hash CC. Bro, get out of here. Okay. Whatever. All right, so then phenethyl bromide. Oh, bromide. Okay, then Linlar, then MCPVA. No, dude, it still didn't do it. Is this the right one? Dude, this is... I was gonna take a picture. It's too dim. Okay, I'm just gonna say what happened. Wait, what commit did it push? That's the main question. What's the latest commit? Is this the latest commit? 6.1b? Yeah, I mean, yeah, it's clearly that. I'm still noticing the issue. If I start with a terminal alkyne, specifically, this would be the acetylide ion of propyne. So C, C, triple bond C. And then I react it with phenethyl bromide for SN2. Then the image that's rendered is that the ring is on the left side and the triple bond is on the right side, which is fine, like no problem there. Then I add Lindlar's and I get a syn addition of H2, so I get a cis alkene. Then, since I don't know, this is just my hunch, but then I do MCPBA and I'm still seeing, even on the right commit I verified, that MCPBA is still adding to the ring. And that the alkene lost its cis stereochemistry. I think it's just that, like, smile. Okay, I don't know what it's talking about. It said MCPBA is fixed if the substrate is the graph key form. Okay, but LinLAR is still generating the next product from the display kekulized smiles, so it hands MCPBA a bad substrate unless RDKit repairs it perfectly. I'm going to make alkyne reactions use the graph key too and preserve structure keys in snapshots restores. I don't really know what that means, but as long as it knows what it means, right? And it gets fixed. And now we got to check for, so if I go back to the alkyne and then I do Na NH3, okay, I get the trans, and then I do MCPBA. It remains trans, but see here how there's no slashes? My expectation is that it's probably not right. I think it's definitely right that Smiles is brittle. So like, I don't know. Smiles is pretty brittle. Are there other cases in which we likely are losing cis trans alkene information? For instance, my guess is that other partial reductions of alkynes are probably wrong too. For example, something like lithium metal and ammonia or sodium metal and ammonia. What about those? See, this is what I wanted from coding all along. Is I always kind of hated coding, but I loved the product of coding. Like you can build just such cool stuff. Like this is objectively sick, and it only took me a few days. Okay, so let's see if this thing works now. So let's see. Do we have a new commit? 6.1 FD. Okay, go. So let's do C minus hash CC phenethyl bromide. Okay, LinLAR MCPBA. Dude, what? What are they? What does it think is happening right now? Bro, this thing is actually pissing me off. It's still broken. Okay, wait. So it didn't make any changes this time. Okay, so wait. Uh, we're just gonna have to keep doing this because there is no way. Okay, so let's just go back. It's actually so annoying. Damn, dude. See, it's doing stuff that I would never have known to do. It's saying that, like, the app.js file is cached. That's crazy. I don't even know if that's true. This is so fun, man.
I'm a licensed farmer.
I'm a licensed geeker. Alright, 7cc. Okay, I think the reason you were still seeing it was browser caching, not the rule code itself. Okay, cool. So let's try it. Okay, we're on the new commit. Alright, so C minus hash CC phenethyl bromide Linlar. Oh, interesting. MCPBA. Okay. I mean, it's fixed. It flipped around the side of it, which I think is interesting, but, you know, whatever. Right? Let's see, what is the pubchem? This must have a pubchem ID. Oh, they name it as the Oxyrain. Okay, cool. So now let's see, how do I open this up? H2O? Epoxide reactions. We can add an alcohol to it? Or an R group from an alcohol? Let's see. Vicinal dial. Is it specifically a transvicinal dial? I think it needs to be a transvicinal dial, so that's something. Okay, alright, fine. But isn't there a substitution counts things? Oh yeah, actually wait, can we do that? I want to check that. So propene, MCPBA, MCPBA. Now, what happens? Let's read what happens. Okay. Here are the core epoxide reaction rules you probably want. Epoxides are strength cyclic ethers. An epoxide is basically a three-membered ring with oxygen. Because the ring is strained, nucleophiles can open it. You know what I want too? I want ring closures and ring openings and like I want intermolecular reactions. Let's keep going. Because the ring is strained, nucleophiles can open it. The universal structural pattern is a nucleophile beta substituted alcohol. Okay. Alright, that makes sense. One epoxide C gets new, the other one gets hydroxide. Basic neutral nucleophile opening. For strong nucleophiles under basic or neutral conditions, the nucleophile attacks the less substituted carbon by SN2. So let's see just if that works. So let's add NaCN, or let's add NaOH. It attacks the less substituted. Wait, but we will have no idea of knowing. So we have to do NaCN. What about MEOH? Um, that's another thing is that like pattern patterns aren't really supported, which maybe is fine, but you kind of want patterns to work, I think. I wish I could just talk to my computer. You know, maybe we'll commit it and then I'll just start a codex thing here. I think I don't know why I wasn't doing that from the beginning. So let me do this really quickly. The other thing is that there's no codex app here, but I guess I can just use it from VS Code. But I gotta make sure that I'm using the same chat because I want to keep it all as one chat. Toggle. Yeah, I don't know why, but like the chats that are running locally over there are not showing up in my IDE. I don't know why, but whatever. Um, can you do this though? Does that work? Uh, wait. Okay, so that works. Okay, well, we fixed some bugs. Dude, this thing is so fun, man. I think the main thing is just like really 10xing the number of tests and and making sure that like it's more because like I don't really know how robust it is. It like all the I know works is just from me testing it out. What are some long multi-step syntheses that every first year OChem student should be able to do? Because like I hate that all the puzzle cases are like propene, propine, acetylide, internal alkyne. Dude, that's like so easy. Okay, yeah, it's probably oxidation stuff. That's probably the because I low key didn't study that in like repeated thing. I don't even know. Do I have any of that? Alkene to an alcohol. Oh, and oxidize a primary or a secondary alcohol. Or no, if I have a primary alcohol, take it to a carboxylic acid. Well, let's try to take it to hexanal. So I think hexanoic acid also smells like a goat. Um. Okay, so yeah, so propene, HBr, ROR. Then now that we have a primary alcohol. Oh wait, actually wait, we didn't want that. We want to go back. We want to add. Is it just H3O H2O2? Wait, anti-Markovnikov. No, no. Oh, I got it. BH3 H2O2 and AOH. Anti-Markovnikov alcohol. Now I want DMP. All right, so maybe that's what we want to do. Okay, great. It works. What are the next big things we need to do? I see that there's probably a lot of stuff related to alcohols, reductions, oxidations, stuff like that. That's I don't think is implemented. I also really want. I think just because it'd be so cool. Like I already like how it works for basically substituted cyclohexanes and doing E2. But I think it would be so cool if we could, because right now what happens is, let's say that we have 1 bromo, 2 methyl cyclohexane, and we do, and I put in a strong base like ethoxide. It comes up with 2 options, which is awesome. The first option, they're both E2. One is the major E2 and the other is the minor E2. But the problem is, well, okay, this is also specifically in the case of trans 1 bromo 2 methyl cyclohexane, because otherwise you would get the Zaitsev. So, anyways, I just think it would be really cool if we could have the power in a general case way to do the anti-periplanar check, which I don't even know how you do it, because, like, let's say you have some cyclohexane. Do you just check both? First, if no stereochemistry is provided, you have to do something, which I don't know what the logical thing there is to do. But in the case that it is provided, then you have to check the chair flips and see, is there a feasible route to getting an anti-periplanar hydrogen, in which case you have to rank them by substitution count or something like that. But I don't know how to make that robust. But yeah, so those are 2 things in my mind that I think are probably important. But there's probably things that you know from writing the code that are way more important to get fundamentally right. So let's just like recap and see what are the next things to carve out to make this like actually useful. Vibe coding is like maybe the most fun I've had coding in my life. I think you need to do 1 and 2 right now because those are like we gotta have that. Otherwise, it's just patching and patching and patching endlessly, and that's just not gonna work. And then alcohols, yeah, do alcohols, but yeah, because that's a big part of chemistry. Okay, and carbonyls, I wouldn't do carbonyls yet because I haven't even read the textbook yet. The exam is in a couple weeks, so let's hold off on carbonyls. Yeah, because I don't know how carbonyls work, to be honest. All right, so yeah, so let's get the alcohols. Let's get the reactions annotations. The reaction annotations. That's gonna be good. Let's see how much. I have 67% left, so I'm actually like doing pretty good. Um, so what happens, for example, if I just say benzene and then MCPPA? So does that actually happen in reality? And the thing is, I'm not even vibe coding the way like people are using coding agents now. Like now it's like you just write something and it just like goes and goes and goes. Which that should be the next thing is to just have it like automate the tests, just keep building it without my input. Because I'm still sort of directing it, which is not like how people do things now. See, it still thinks that it's all just, bro, we moved on from that. But yeah, man, dude, people are using 100 million tokens a day. That's crazy. How many tokens have I? 100 million tokens a day is crazy. How do you even use that many tokens a day? But that would be really cool if we could just start to automate, like going through, like take a textbook and somehow get the structured info and then just have it churn through all the cases, you know? So yeah, benzene epoxide is not right, I don't think. I love that it can just like run the tests and be like, did I regress? Like, ugh, vibe coding is so fun, man. I mean, this is useful. This is useful, dude. There's still some rough edges, but like, okay, I think it's probably time to do some homework. You're now ready to see how altering flammabilities affects forest dynamics. Adjusted values. Okay, do I reset? Okay, reset, run. Okay. Based on the bar graph to the right, what does the forest community look like now? It's very uneven. Yeah, that makes sense. So, okay, whatever. Oh, yes, the automator. You'll now run the simulation using 6 different probabilities of spread. Okay. Set fire frequency to 2 fires a year and choose your initial probability of spread. Okay. How many results do I need? 5 runs? Okay. Oh, wait, no. 6. Okay, point 1, point 2. Oh, bro. Damn it. It's like, why doesn't it just write down the data for me? It's like, why do I need to be the one to put this in? So he goes up to 1, so point 2. Okay. Yeah, okay. How did altering flammabilities affect competition between oak and sugar maple? So, sugar maple is way more flammable. But if we change it to 0.5, Click plot data. What? Oh, I see. Okay. Force dynamics depend on underlying mechanisms. Which of the following changes to the model's transition matrix would reduce the importance of facilitation while allowing? Okay, I gotta read it then. What drives succession? First, the forest model is based on the assumption that succession is being driven by facilitation. All right. Um, as a result, the model's transition matrix assumes a strict sequence in which later successional species cannot establish until facilitation. Oh, what? Which of the following changes to the model's transition matrix would reduce the importance of facilitation while still allowing succession to proceed? Probably this then, right? So persistence is the diagonal of the matrix. Maybe. I don't know. That seems a little tenuous to me. Can't I just see the matrix? Why do I have to look at the rows or the columns? Wait, can we go to... Oh, so default makes it 0. What? Oh, did I not do settlement? Maybe I didn't do settlement. Oh, okay. What is it? It's like if you have a transition matrix, the best thing to do is to diagonalize it, because then you just iterate. Then you just take powers of the eigenvalue or the diagonalized matrix, right? Something like that. I'm pretty sure that's right. Let me just check. Adjusted. Adjusted. Number of individuals seems ridiculous, doesn't it? I don't know. To me, that seems like a little weird. Is that really the right metric? I mean, I don't know. Like, fundamentally, can you even say anything about ecosystem health? Like, what does that even mean? The results can help explain the historic dominance of oak in eastern deciduous forests. When fires are common, sugar maples are kept in check and oaks are abundant. Second, your data clearly show that disturbance and succession can drive changes in community composition that by documenting home shape. These findings not only answer but also generate questions. Some questions relate to the type of community impacted by fire. For example, is the effect of fire on Rocky Mountain coniferous forests? Oh, was that part one? What? With default settings, oak trees in the simulated forest are less abundant and sugar maples are more abundant. Based on. Bro, okay, fine. Ecological succession refers to which of the following? Succession may be driven by a number of different mechanisms, which is a good example of facilitation. Which of the following statements about models is true? Um, it's either between one or three. I don't think they must be simple, but it's probably A. Three of the four statements below help explain the shift in dominance. I don't know this one. All right, so I'm gonna submit what I have, but I also want to know the answers because this thing doesn't tell you the freaking answers. It's so annoying. Yeah. I mean, these ones were easy. I can't tell which is C, but it's obviously this one. 7. Okay, so I got the same answers as chat. That's what I thought. I mean, I got them all right. Okay. Wait, is there more? No. So now, wait, am I done? Bro, I hate when I accidentally do one of them wrong. Am I good? Okay. Now I gotta do this thing. Sickle cell alleles. right. Wait, let's try wait. Uh wait, can we try a Grignard? Um no wait. Oh, that's cool. Wait, why is it? Oh, dude, this is so fucking good, man. Yo, literally, this is so sick. Import a molecule, then transform it step by step. This thing is so fun, man. I literally love this. I literally love this. Ha. All right. Um. Wait. So wait. Okay. Hold on. I was trying to do a basic Grignard reaction. So first I started with bromobutane, then I added magnesium, and I got the Grignard reagent, which was good. But then I tried to react it with formaldehyde, and nothing. It said no product rule. And um, also, I see here that it um well, okay. I mean, maybe in the future, maybe write this down somewhere. I don't know, but you know, to me, a reagent, like an input to the reagent, like Linlars, typically what you do in the exam or the classroom is you have a substrate, you draw an arrow, then you write one something, two something, and that list um, is important because not only in the one you can have multiple things, right? So let's say like I don't know, maybe borohydration. You add peroxide, BH3 or whatever, and there's a number of things in there. And then there's a two, and so it's not the I guess the data type of a reaction and or reagent, and this you don't have to write any code based on this, but I'm trying to work out what the proper mental model and design is. That you basically have a list of sets. So a set could be a list of chemicals. Um, the most common case would be some sort of reagent or catalyst, and then a solvent, and then there's a list that says the basically the ordered steps that you have to take to achieve the desired transition, and um, and yeah, so that's sort of the mental model that I have is there any problems with that, or is there a deviation for how we model it in the software? And because one thing that I think would be nice is, when I type in a reagent like Limlar, uh, let's see, if I propene, um, like, I guess what I'm saying is that, um, I would like, um, to maybe be able to, um, look at these reagents or reagent sets or whatever you call it, basically the agent of a transformation, the unit of, the edge of the graph that takes a substrate to its product. And um, maybe be able to, because I think it would be really cool to have the, to be able to go to the pubchem chemicals for the reagents. Um, but of course, I really don't want to make the UI like additionally clunky because of it. But I think it symbolizes uh, the the unity of the fact that reagents are not like special class things. While there may be special named or whatever reagent sets, that we use as mental models as the like identifier for some sort of transformation, uh, under the hood, those are still, chemicals, I guess. Because I think there's maybe two domains of vibe coding. One, you really do not care at all how it's done, and two, you use it as a tool to further your own learning. And I think that's probably where this comes in. This project comes in for me is like, um, Like, is this slop? I don't feel like this is not slop. I don't think that's right. Is that right? I think it further oxidizes to CO2. Might need to fix that. Wait, let's try. What is the? Would it be hard to implement something where um, basically, let's say that I do a path. You know, I can of course copy the serialized path and send it to someone, but it would also be cool if I could like uh, have it generate a URL, and then I don't know if this is even possible, but then if I just copy that URL into my browser, then it perfectly loads the state of the thing. Is that possible? I don't care about a long URL. I think the first way is good. Oh, I'm at 1% left. Damn. All right, well, so that's a good time to go finish this homework. Let's see. Okay, so that's pretty sick. Dude, so sick. Dude, this thing is so fun, man. It's so delightful. Ugh, it's great. I wish I had more credits. After doing this, it's so hard to go to this. All right, let's just get it done. Sickle cell disease. I mean, I'm actually interested in this. Is an inherited disease in which people produce malformed blood cells that are. I think it's pretty amazing that the heterozygous people aren't affected more. There's no. Oh wait. Oh, okay. Yeah, there's nobody with sickle cell currently in the community. Okay. Wait, how do you even know that? You can't know that, right? You only know the allele frequency. You don't know the. How do you? How is it? How do you know that? I don't know. I don't know how you know that. Well, yeah, no shit. 300 plus 200. Why is that? If nobody dies from malaria, That makes sense. So then, so the susceptible people are the homozygous wild type. I think that's what you call it. That HBA. And so if malaria kills, you're selecting against that homozygous HBA. So if it doesn't kill, then those guys are fine. But then there is a net pull away from alleles in the HBS case because offspring will not reproduce. Okay, all right. I think I understand this graph. Dude, malaria is brutal. Holy cow. HBS 0.45 and sickle cell is 74. Okay, slightly wet. Reset step 0.36 and 52. Based on what you know. Bees. All right. And the advantage and disadvantage in which. Jeez. Um, in which region do you think the frequency should be the highest relative to the areas? Yeah. See if you're correct, select the genotype, run the simulation until the frequency is level off. Wait, what? I don't think that's right. I think that this thing is bugged. Yeah, see? Found a bug. Four parts, bro? Come on, man. Find the initial number of HBS carriers. Okay. It's like so slow, dude. Dude, there's no speed thing. Come on, man. Let's see, how does this thing look on the phone now? Does it still look good? That was weird. Oh, wow. Okay, great. You gotta sit here and watch it, too. Alright, I'm gonna go to the bathroom. 0.52, 0.51. 0.52, 0.51, 0, 8, 8. Which population were allele frequencies most stable? Because genetic drift is the result of random events, a replicated experiment can determine whether larger populations are more buffered from genetic drift than smaller ones. This is in the scenario where sickle cell is not a problem, right? Repeat the process 9 more times? Dude, you gotta be kidding me. 0.36. Okay. Okay. Yeah. No natural selection. No genetic drift. No mutation. No migration. And random mating. If the frequency of HBA homozygote, what's the value of p squared? Point. Wait, what? Wait. No. P squared is this. So square root of that. Square root of 0.1. What? The frequency of HBA homozygotes is 0.1. So p squared equals 0.1. Oh, wait, I'm so dumb. Bro. I thought they were asking something else. Suppose the frequency of homozygotes. Uh. 0.19. Did I do my math right? So q squared. Okay, so q equals 0.1, p equals 0.9. Yeah, that's the way I think about it. Is the population is so large, the genetic drift doesn't happen. That means that the population must be infinity. I'm not using that fucking calculator. Okay. Wait. This gives the. Oh, okay. Wait. Hold on. No, no, no. Wait. Q squared equals S. So Q. So 1 minus square root. Okay. 1 minus X. No, wait. Q is equal to square root 0.83. So P is equal to 1 minus Q. So P squared. Oh, yeah. That's actually. Okay. That makes sense. In the population's union revolution, which hypothesis would be supported by. Wait. An alternative hypothesis for stating that heterozygotes have a fitness advantage. Oh, wait, why did I write less? HB is 0.43. What is the observed frequency of heterozygotes? Is that right? Okay. I hate that. Okay. Is this right though? 0.22.19. Is that what I'm? Let me just figure out if that's what I'm supposed to do. Oh, because this is supposed to be the P. Okay. Which of the following is false? Wait, what? What am I doing? Wait, hold on. Wait, bro, what am I tripping out about, dude? Which of the following would be sufficient for the Hardy-Weinberg equation to accurately predict genotype frequencies from allele frequencies? Okay, so q squared 0.1. So square root, so q is equal to square root q2. So what is the expected frequency? I think it's just 0.32. In a population where the proportion of individuals who are susceptible to malaria is so p squared equals 0.31. If the cystic fibrosis allele protects against tuberculosis the same way the sickle cell allele protects against malaria, then which of the following should be true of a comparison between regions with and without tuberculosis? Um, I would say cystic fibrosis deaths should be more common in regions with tuberculosis because the allele will be more frequent. A person who is heterozygous for the cystic fibrosis allele Bro, why is there always one that I miss? How does that happen? What is the observed frequency of heterozygotes? Oh. All right, bio homework done.